If you're writing Python scripts, sadly but unavoidably, sooner or later you're going to run into errors. For example, your script works perfectly on your machine, but the moment a colleague tries to run it, everything falls apart, and we end up not looking so good. So we want our scripts and tools to be robust and to handle errors professionally. And we can do this by anticipating errors to keep them running and provide meaningful messages when things do go wrong, instead of the cryptic messages the Python interpreter might provide. And in this video, we'll look at the tools Python and ArcPy provide for proper error handling. So if your code fails, we want it to fail gracefully. The first thing Python provides, like a lot of programming languages, are try blocks. This is where a block of code can be executed, and if an error occurs, rather than crashing and the program stopping, it can be caught in an exception and handled. So should code fail in the try, it will immediately jump to the except section and execute the code there. And in this way, we can anticipate potential errors and write code to handle those errors. ArcPy provides a specific exception, execute error. We define the exception by putting arcpy.executeError after the except statement. This exception is only raised when an ArcGIS geoprocessing tool fails. So we could wrap an ArcPy geoprocessing tool that we think might fail in a try block and then catch that exception. In this example, if an exception is raised, we are printing out all the messages, which will include error messages from the geoprocessing tool. If we have more code after the except statement, the program will continue to execute. So you're not getting a crash. Now, you might not want this, in which case you would have to write code to exit in the exception. So let's have a look at another example. And with this bit of code here, we are in fact buffering a line layer. And the line layer is this rivers layer, which we pass into the buffer tool as a parameter. We're also specifying the buffer distance as 500 meters, which also goes into the buffer tool as a parameter. And then the output is going to be this rivers buffered, and that's going to be a polygon layer, which is the buffer around the river. So a very simple little script, and let's have a look at the project. So in this project, we can see that there is in fact a mistake. The rivers layer is in fact called river in the script, so there's an S missing from the script. So that script is going to fail. So let's see what happens. So if we paste in the Python, and then let's just execute that, and we can see that it just crashes out and we get the stack trace that is the actual information we need, which is right at the bottom, which says dataset river does not exist or is not supported, but not too clear, and we can certainly handle that better and more elegantly. So let's go back to the Python and consider what we do if we were going to handle this error. So this is the same code, except this time we've put the ArcPy buffer tool in a try block. So the try will execute and any errors will be caught in the arcpy.executeError. And what we're going to do in this case is we're just going to print out the messages. So we've got a bit of text here, ArcPy tool error, but we could put whatever we wanted there. We could be more specific if we wanted and say buffer error. Then we've got the arcpy.getMessages. So that's going to get the last error messages from the geoprocessing tool. So let's go back to the project and let's remove the previous script. And let's paste in the updated script and execute that. And it fails again, but this time we're not getting all of the red text and the stack trace and everything. So we're failing because we're still passing it the incorrect name of the layer. But now we're getting that bit of text we put in the exception, that ArcPy tool error. So that's telling us what type of error it is. And then we're still getting the same message from the tool log, which is the dataset river does not exist or is not supported. So the fail has been handled more elegantly in a more controlled way this time. So let's develop that further. And what we can do is we can have multiple exceptions to handle different errors and to be able to handle them appropriately. So again, this is the same script, but this time at the start of the try block, we are testing to see if that layer river actually exists with the arcpy.exist function. And then if it doesn't exist, we are deliberately initiating this file not found error with this raise keyword. Now that's a built-in Python exception. That's not an arcpy exception. And that will execute the except down here, the file not found error, and we'll print out the Python interpreter error from there. Now, if it gets past that, so in other words, if the river layer does exist, we will then execute the buffer tool. And once again, should that fail for any reason, that will then hit the arcpy.execute error exception, and once again we'll be printing out an arcpy tool error with any messages that go with the geoprocessing tool. And then finally we have a general Python exception at the bottom should it fail for any other reason, and we're printing out unexpected error and any messages that go with the Python interpreter from that. So we're handling every possible error, and we can see why the script might have failed. So let's go to the project again and see how that will execute. So if we clear the previous text and then paste in the updated Python, and then let's execute that. So what we can see immediately is we are getting the error at the bottom, feature class not found river. So that is from the file not found error exception. So it's very, very clear. So let's just clear that and let's try and fix that. So if we can actually go back by pressing the up arrow, and that will put the previous code back up. And what we can do, let's fix this river. So let's make it rivers, which is the actual name of the layer. So this now should execute. So we should go beyond the file not found error, and we should go and execute the tool, the buffer tool. However, there is a further error in this code, and we're looking at the buffer distance parameter. It says 500 meters. This is using the British spelling, and the buffer tool will use the US spelling. So this will fail. So let's see what will happen this time. Let's execute that. So this time we go past the file not found error. That's okay because we fixed that. And instead we've executed the arcpy.execute error exception. And once again, we get that arcpy tool error, bit of text there, failed to execute, parameters are not valid. And here we have the specific error, which is field 500 meters does not exist within the table. So again, it's telling us that that parameter 500 meters is not correct. So let's remove that. So let's fix both of those. Again, using the up arrow key, I can bring up the previous code again. So we've got rivers, that's correct. And let's change this to the spelling the tool expects, 500 meters, and let's execute that. So no error messages this time, script completed at the bottom, and in fact we have now got our buffer being created around our rivers layer, and the whole code has executed successfully. So those are examples of error handling in try blocks. Now those are very simple scripts. We probably wouldn't need error handling in such short scripts executed in the Python window. But if we were using longer scripts or creating Python toolboxes or script tools, then we may need error handling. Now the way we've been handling those exceptions is to print out error messages. Now we could do other things. We might want to just skip a process and carry on. We might want to delete a file to clean up, but we'd certainly want to print out any error messages we saw. But if we were in a Python toolbox, we would not be able to use the print statement, as we won't see that. Instead, we need to use the arcpy message functions. And there are a few of these. We've got arcpy.addMessage, which just prints out a standard message. We've got arcpy.addWarning. This is if there hasn't been an error as such, but something isn't quite right and we want to alert the user to this. And the arcpy.addError, where we've clearly something has gone wrong. And all of these will be printed out to the tool log. So let's have a look at how that might work. So we have this Python toolbox here, which is called buffer field above threshold. And what this will do is it will buffer a feature based on a field, but only if the feature is above a certain threshold. So we've got an example here. We've got this layer data centers. We've got this field clearance required, and we've got some values in there. And we can buffer these data centers based on these values, but only if they're above a certain number. So let's have a look at the script. So if we go to the execute function, which is the main function in a Python toolbox, and I do have a video showing how to create Python toolboxes, what this function is doing is it is taking a layer, it is performing a selection query over that to see how many features in that layer are above the threshold, and then it is running the buffer over that layer. So we've got a lot of messages in here. We've got some add message, which is just going to be some standard messages we're printing to the log. We've got an if statement here. Now we're counting the number of features that meet our criteria, so the number of features that are above that threshold. And if there are more than 0, we're going to run the buffer. But if there aren't any, so in other words, the threshold is perhaps too high, we're going to add a warning in the else statement here. So it's not an error as such. We're not going into an exception. We do want to alert the user that no buffering has occurred. So we're going to add a warning here with this text, which will print to the log. So let's have a look how that would work. So let's set up the tool. So we're going to add the layer we're going to buffer. We're going to put in the field that we're going to buffer, that clearance required field, and then we're going to add a threshold value. So let's put in 1,000, so none of the values are above 1,000, so nothing will be buffered. And let's run that tool. And what we can see at the bottom is we are just getting the warning. So that add warning arcpy statement has been executed. So let's have a look at the log through the view details, and we can see here is our message that we put in the add warning. No buffering as no features above the threshold. So that part of our script has executed. So we informed the user that nothing has happened. So it's a warning, it's not an error as such. So let's consider now if we want to trigger an error. So let's move the threshold value down to something that will work. So 150, we've got values above 150, so that's no problem. But let's put an error in the field. So let's misname the field. So let's remove something there. So this is clearly a field that doesn't exist. So this is going to fail when the buffer is executed. It's going to determine that there are features above 150, so the buffer will execute. That will fail, and that will go into our exception, our arcpy.execute error exception. So let's see that. And we can see tool failed, and if we look at the log, we've got our bit of text here, arcpy error, and expected field was not found or could not be retrieved properly. That is from the geoprocessing log, the arcpy.getMessages. So our exception has been triggered, and we've provided appropriate messages to the user. So if we remove all of that, if we put the correct field name in and let's run it again, now our tool completes successfully. We've got our buffered data centers where we're above the threshold. We've got the log. We've got some of those add messages we put in, the buffering selected features, the buffer output saved to. So the arcpy.add message, they're not color coded in the log. They're just there to provide info for the user about what has gone on. So we can print out errors and warnings using the arcpy functions to the tool log, or we can print to the Python window. But another option is we can print to a log file. And this can be especially valuable if we've got more complex or long-running scripts. And Python has a built-in logging tool to do this. So let's have a look how that would work. So if we go back to our script, and this is the same script we were using before, and we'll just look at it in the Python window just for ease of understanding this. And it's the same script where we're going to buffer a layer called river. And we've got a try block, and we've got the exception handling for the errors. But this time we're defining the log file, and we're going to print some of those errors to the log file. So the way we do that is, first of all, we're going to import logging. This is a Python library, so we need to do that. And then we need to configure the log. So here we've got this logging.basic-config. So the first thing is to define the file that we're going to create the log to, and it's called buffer log. It's a text file, and the location is defined, which is just the same location as the ArcGIS Pro project. We've got the level of logging. Here it's logging.info. You can have logging.error, but logging.info means you can capture all kinds of information. It's more of a general format. And then we've got the format the actual log is going to be written to. So the first thing is we're going to write the time the log entry was made, then the level, so was it an error, general info, or a warning, and then the actual message, the log message. So that's the format defined. So once we've got the log set up in the basic info, we can actually write things to the log. So the first thing we're doing in the script here is a bit lower down. We've got logging.info. So this is just general information, and then we're printing attempting to buffer. We've got the layer name and the buffer distance. So just general information, just so when we look at the log, we know exactly where we are in the script. Now in the script, we're in the try block. We are going to test for the existence of the layer we're looking to buffer, this river. And as there's a spelling mistake, there's a missing S from the river, we will raise a file not found exception. So that's going to go down to the exception, and we are going to print that out, but we're also going to log the error. So we've got this logging.error. So that'll put another line in the log, and the script will end at the exception. So let's see how that will look in the project. So let's just paste in that code and execute it in the Python window. Now, if we go to File Explorer and look in the project folder, we can now see the log file has been created. So let's have a look what that'll look like. And we can see the two entries. So we've got the first entry where it hit that info line in the script. So attempting to buffer river by 500 meters. Now the next entry is going to be from the exception. So we've got the type of entry, which is an error, and then feature class not found river. So we've logged the whole information into a log file as well as just printing them out. So we know exactly what's going on looking at the log file. So let's have a look at that. Let's fix that. So using again the up arrow on the keyboard, we can put up the script from the previous entry. Let's fix the name of the layer we're going to buffer. So this should now execute successfully. And let's increase the value just so it's clear. Let's buffer it by 1,000 meters and then execute that. Okay, so we've now buffered that rivers layer. Let's go back to the log and have a look. And again, you can see the previous entries from the previous tool run. So we're appending to the log file here. And so a new entry, we've got info. Again, we've got that attempting to buffer rivers by 1,000 meters this time. And then we've got another info, buffer completed successfully. So this is after the tool has run. So we know that that script has executed successfully and everything's been logged. So that's error handling in ArcGIS. We can handle errors through exceptions, and we can print either to the Python window or to the script log, or we can log to an external file. I hope that's been useful.